So welcome everyone. We are now on week number 5. This is lecture number 9, and we are going to start with a question on the quiz, which was this one. And it says the cappuccino vending machine is designed to dispense an average of mu ounces per cup. Well, we don't know what mu is, but we do know that it's normally distributed, which means that if I were to make a graph of this distribution, what would it look like? What would the graph look like?
Like a parabola?
Not a parabola, because a parabola goes down forever, and this one has to be above the x-axis. It's a bell curve, right? Correct? Yes, no, maybe so, everyone?
Yes.
Yeah.
Something was funny, and I feel like it wasn't me. So anyways, so it's a bell curve. The center is mu, and the standard deviation is 0.4 ounces. And what value should mu be set to? So 6-ounce cups will only overflow 2% of the time, which means, and I'm going to share my screen in a second.
0.02.
Yeah, but I want to share my screen here. So hold on. This is how I set up my picture. Pictures say 1,000 words, so I'm going to stop talking. But this is how I set up my picture. Do we agree that this picture represents the problem?
Yes.
Okay. So the question is, what is mu? Now, if you try to do it straight from your calculator, the only way to do it in your calculator is plug and chug. Try each number to see which one gives you 2% past 6 until you hit the right one. And there's nothing wrong with doing it that way. So when I look at the possible answers on the quiz, if I do 6.82, for example, which is the first one, here are my options: 6.82, 6.00, 5.18, and 5.60. So if I want to check 6.82, what would I do?
You would use the reverse norm or something like that.
Inverse norm, correct?
And then if you're using like, you would use the right side, it would be 98%, 0.98.
Well, you mean if I'm using the left side, it's 98%.
Yeah.
Okay. With what mean and what standard deviation?
You would use one of the numbers from the thing.
Okay, so let's see, I did 6.82. Let's see, I tried that one.
And then you use 0.4 as the standard deviation.
Okay, and it will give me, 7.64, which means if mu was really 6.82, then 7.64 is the value for which 2% would overflow. Is that what I'm looking for? Is that correct?
No, you're trying to closer to 6.
Closer to 6. Okay, so let's try 6.0 now. So second inverse norm, the only change I'm going to make is make my mu 6.00. Everything else is exactly the same. And this one gives me 6.82. Is that correct?
No.
Doesn't look like it. Now let's try 5.18. Do the same thing. Change it to 5.18. Go down to the bottom. This one gives me 6.00.
That's correct.
Okay, there you go. Now, the next question is, was this one doable without the calculator? And the answer is yes, but it's a little more complicated. So let's go through it. What's the other approach? The other approach is to calculate the z-score for this value. How do I calculate the z-score for that value?
Was the z-score the mean minus x over?
I think it's x minus mean over standard deviation.
That's assuming you have all those things. So I'm not looking for the formula to calculate the z-score. I'm asking for the actual z-score of 6. If I have 2% to the right, this alone should be enough for me to calculate my z-score with no other information. Because what do I know about a z-score? A z-score has a mean of what? And a deviation of what? For z-scores, what is the mean and deviation for z every single time? The standard normal distribution. What-
68.
No. What do you get 68? Oh, no. I don't mean the percent. I mean the standard normal distribution, not any normal, but the standard normal, the one that we use to go to the tables in the back of the book.
Is it
Nope.
1 and 1?
It's 0 and 1.
0 and 1.
0 and 1. So what I'm going to do is I'm going to calculate what z value for a 0-1 distribution, what z value gives me 2%. So go ahead and do that. What z value is that? That gives me 2%. You should be able to do that on your calculator. By the way, these problems are physically, mathematically impossible to do by hand. It's not, oh, I'm only a freshman in college, so I'll do it with my calculator. But later on, I'll learn a more sophisticated way. No, these problems cannot be done by hand. Only by calculator or computer or by tables or something like that. So there's no other approach. I mean, conceptually, it helps to understand what's going on behind the scenes. But in terms of actually solving it, these are purely calculator problems. So what does the calculator give us for a 2% to the right, mean 0, sigma 1 problem? What's my z-score? How do I calculate that? I mean, it's the same thing we did above. How do I calculate the point with 2% to the right when the mean is 0 and sigma is 1? Anyone?
The inverse norm.
Inverse norm, 2% to the right, mean 1, mean 0, sigma 1. What do I get? What does my calculator give me on that?
2.053.
2.0537 approximately, right?
Yes.
And the z-score is data point minus mu over sigma. If I solve this for mu, what do I get? Mu equals what?
Oh, 6 point and like a really small number.
First you cross multiply, 2.0537 times 0.4 equals 6 minus mu. So mu is equal to 6 minus that number. I get 5.1785.
Would it be negative?
Nope. 6 minus mu equals 0.82150. So if I add mu and subtract, I get mu equals 6 minus 0.82150.
Oh, okay.
Which of course is just that number. Make sense? I hope.
Yes.
Any other questions on the quiz? No?
Could we do one more?
Sure. That's why I kind of asked. Which
Yeah.
one?
Can we do number 7?
Number 7. Okay, number 7. So let me share my screen here. And number 7 is share screen. Okay. So 7. It says a high-profile consulting company chooses its new entry-level employees from a pool of recent college graduates using a 5-step interview process. Unfortunately, there are usually more candidates who complete the interview process than the number of new positions that are available. As a result, cumulative GPA is used as a tiebreaker. GPAs for the success. Okay, everything so far has been very interesting, but nothing to use so far. GPAs for the successful interviewees are normally distributed, which means what? Normally distributed means what?
It's part of, it has a bell curve.
Bell curve. That's it. Bell curve. With a mean of 3.3. What does that mean?
Middle would be 3.3.
3.3 and a standard deviation of 0.4. What does that mean?
Both sides from deviation would be 0.4
To what?
to 3.3.
No, I'm saying if 3.3 is the center, 0.4, you said,
Minus.
right, until where? I mean, how far is 0.4? Not numbers,
2.9 and 3.7.
right, but not numbers, but just so I have a graphical.
7% is going to fall within that standard deviation.
Okay, so it's to the point where I have 68% of my data, but it's also 2.9 and 3.7. That's correct as well. But what I was looking for was it's the point where it changes from being like a hill to being like a bowl, right? It's a physical point on the graph. But yes, it's 68% as between those two numbers. Now, out of 163 people who made it through the interview process, only 121 can be hired. What cutoff GPA should the company use? So 121 hired out of 163 people. And the options are A, 3.00, B, 3.04, C, 3.08, and D, 3.12. So I'm going to stop sharing a computer right now and start sharing on here. Okay, and the question is, how do I solve for this? So remember, it's all about area. It's all about probabilities. It's all about percentages. 121 hired out of 163. How many is that? What percentage of people am I going to hire?
It'd be 0.74233.
Okay, so keeping all decimals on my calculator, but only writing 3, I'm going to hire the top 74.2%. Correct?
Yes.
Okay, so where is the location of my diagram that cuts off the top 74.2% from everyone who does not get hired? Roughly, where is it?
It's to the left side, right?
It's somewhere to the left, right? It's let's see about there, right? Graphing wise, here is going to be, okay, this will take a while, but here on this side is going to be the 74.2% side. So we're looking for the cutoff point. We're looking for the cutoff point that cuts off 74.2%. How do I find that?
You subtract the percentage we have
Do we,
by 1.
do we have a percentage?
The 74.2,
So subtract that from what?
100%.
Because your calculator is on the left side.
Okay.
Oh, okay. My calculator is the right side. So I just put in 74.2%. And when I put in 74.2% into the calculator with a mean of 3.3 and a deviation of 0.4, what number pops out? Again, this is a pure calculator problem. You can't do this by hand. You can approximate it by hand, but you can't do it by hand.
3.04.
And that's your answer. 3.04 would then be the cutoff of the top 74.2% from everyone else. Does that make sense?
Yes.
Okay. Okay. Yeah. So that's it for the quiz. I hope. I'm going to close it now. And I am going to open the book and we are going to continue. So chapter 4 and 5 homeworks are up. We did them. And we are now going to skip a little. Hold on, I have my syllabus here, or at least my chapter. Here we go, possible daily schedule. So we did 4 and 5. And we're now in week number 5. And when I look at the schedule that the department gave me for week number 5, it says that we're finishing chapter 5 today, but did we finish 5 last time? Or did we have more to go? Anyone recall whether we finished it or not?
What was
I
number?
was not.
What was
I was
number
not here,
5?
so maybe we can.
5 was regression. 4 was scatter plots. And 5 was the best fit line. I know we certainly started the best fit line. And I'm pretty sure we finished it, but I'm teaching 3 stat classes. So sometimes I get confused with what I finished covering.
The last notes I have on it, I think it says inflectional observation as
Influential observations.
that influential.
Did we do extrapolation? Did I talk about like never to go outside the data range?
Yes.
Okay, so we finished chapter 5, which is very good because according to the roster, all that's left for this week is chapter 8. Now, I mentioned this to you guys last time. In 2 days from now, on Thursday, I will be in the airport when class pops up. So I am going to try my best to find a quiet little corner and log in and teach from there. If I am unsuccessful, if it's not working, then I will have a class where you get to ask questions if you have them, and I won't teach, but rather I'll just be there to answer questions. I don't want to get a sub. I don't want to just not have class. So we're going to have class. Attendance will be taken, but there's always the possibility that class will be either cut short early or just it'll be too difficult to actually teach, but I'll do my best to at least answer questions. So that'll be Thursday. So today we're going to do chapter 8. And that way, either way, by the time this week closes, we'll be on task. Okay, and I'm going to put up the chapter 8 homework as well when we're done, so you can start that. Okay, chapter 8 is a non-mathematical chapter this Thursday. Yes, 2 days from today. I have a tournament in Arizona that I'm going to.
Are you excited?
Am I excited? Am I excited? Let's put it this way. I'm not really truly hopeful that we're going to win. I hope I win too, of course. I'm not really hopeful that we're going to win. But then again, I wasn't hopeful that we were going to win at the last stage before this, and we did. So I might be surprised. But I'm spending a lot of money for this weekend. It's not just what I'm spending, it's also what I'm not making, because usually on a weekend I'll make about $1,000 tutoring. And so I'm not doing any tutoring this weekend. Plus you have the hotel, that's like $300, and then you have the rental car, and then you have the flights, and then you have everything else. So it's like about $2,000, you know, a $2,000 swing for this weekend that I'm playing, you know, 46 matches. I don't know. So if we win, I'll be very excited. But if we don't, all I'm going to think about is what might have been.
What are the prizes?
Well, the prizes are not monetary. You know, maybe you get a gift card to something or other, but it's more just knowing that you are the top team at that level in the country, which you know, is a nice feeling, but it doesn't get me anything, if you know what I'm saying. Anyway, it's not like I'm going
Supposed to be
through.
hot?
Huh?
Is it supposed to be hot over there?
Well, Arizona's always hot, isn't it? Oh no,
Yeah.
Vegas is always hot. What's Arizona like?
I think Arizona is very hot, but I mean,
It is big time.
Hey guys, we live in the valley. Can it get any hotter than this?
way harder.
Yeah.
Well, shit. Okay, well, let's hope it doesn't. Anyways, chapter 8 is on producing data. If anyone wants to come, by the way, and cheer me on, I'll give you an A, or at least I'll give you extra credit. I can't promise an A, but
Wait,
If
where
A
is
is
this
a
again?
deal, I'm in.
it's in Surprise, Arizona. It's outside of Phoenix.
Where do we buy tickets for this? Like that ass.
I'm flying from Burbank, so it's like $100 for the flight. It's not bad, monetary wise. Anyways, okay, so let's get a van and all go. That's what I'm talking about. Booyah! Send the address. Okay, it's like you know, tennis place, Surprise, Arizona. How many can there be, right? It's like I'll bring the glitter and signs. Oh, I don't know. Every time I know people are watching me that I know, I always try a little bit too hard. And it's like, you know, I want to show off and like, you know, do amazing. What?
Are you doing remote teaching now?
Yes, I'm teaching. Like they're literally right there watching. They can hear you.
Hi, guys.
Oh, Jesus Christ. Sure, do me a favor. Can I get more coffee?
Sure.
Thanks. Thanks, Dad. You're the best. I'll go away. Okay, so chapter 8 on producing data, sampling. So up until now, everything has been about using the data once you have it. Getting a mean, getting a median, getting the IQR, finding outliers, doing this, doing that. Everything has been about using the information that you had. But this chapter takes a step back and says, how do you actually get the data in the first place? So we start off with the difference between the population and a sample. Now, this is a very important distinction, which is not really usually complicated. The population is the collection of every single individual in whatever you're studying. So if I'm interested in the average height of every CSUN student, my population would be every CSUN student. If I'm interested in, you know, the who's going to win the next election, I might have as my population all registered voters. You know, every situation, you'll have a different population, which is the collection of every individual in the study. Usually, it's not cost effective to interview or to ascertain from every single individual their contribution to the overall data set. For example, if I want the average height of every CSUN student, there's something like 40,000 CSUN students, right? Somewhere in that vicinity. I think it's like 40,000. So if I'm really, really invested in making sure nobody lies about their heights and gives wrong data, I might feel that I need to do the data collection myself. Is it feasible for me to measure 40,000 people myself? It's not feasible. And even if I had a team helping me, it's just not really realistic. It takes too much time. it takes too much money, etc. So what do? I take a sample. I take a smaller portion of the population and I determine the data from the sample. And then hopefully I do it in a way where I can infer from the sample knowledge about the population. So for example, if I measure the heights of 100 CSUN students and I get 5'8", is it reasonable to think that the overall population is in the vicinity of 5'8"?
Not really.
Why not?
I mean, you're averaging 100 out of 40,000, right?
Yeah, but the question is, how much do I have to average before, or do I have to sample before I feel it's large enough to give me a reasonable representative value? Should it depend upon the population size? Like a bigger population, should that require a bigger sample?
Yes.
So let me ask you a question. You ever make soup?
Yes.
You ever want to test if your soup was ready before you take it off the stove or something? Or can you imagine wanting to test to see if your soup is ready before you take it off the stove?
Yes.
No, I guess you gotta try it.
You try it, right? You dip your spoon in and you take a little sip and you see if it's good, right?
100%.
Okay, now imagine you're a caterer and you're making a soup for a big party of hundreds of people. And you want to test if the soup is ready. What would you do?
Just test it with a spoon.
And how big would you use a bigger spoon because the pot is bigger?
No.
Not really, no.
No, because if the sample is large enough, it doesn't matter how big the population is. And hopefully that soup example kind of illustrates that idea.
Yeah, it does. Great example,
Oh,
actually.
thank you. Oh my God. That's a way to think. Now, the question is 100 people enough in the case of CSUN to feel that my representation from the sample is large, is in the vicinity of whatever the true value is? Is 100 enough? And yeah, go ahead.
Oh, I was gonna say, wouldn't like the gender of a person and like their height also change the data?
Well,
Girls
what-
tend to be shorter than guys do, so wouldn't that like?
well, if I want the average of all CSUN students, and I only asked guys, or I only asked girls, I might question my data set, right?
Yeah.
But if I had a random sample and I had like 47 guys and 53 girls, shouldn't the average kind of take into account this disparity?
Yeah, I guess.
Maybe. The question is, does it? And as we're going to see throughout this course, we're going to see exactly how big of a sample is necessary for various situations. Literally, thank you. Literally to the number. Like, okay, 942, that's good enough. But 941, no, that's too small. Okay, we're going to actually do some computations to actually compute what sample size do I need to ensure this or to ensure that. But it's not just the sample size that's enough. Suppose I suppose I was interested in everyone's favorite sport. Okay, so people right now in chat, what's your favorite sport? Just throw it out there. What's your favorite sport?
Basketball.
Okay, so the whole chat thing might have been a little too difficult. I get that, but I'm just kidding. Basketball, football, golf, good call. Another basketball, soccer. Anyways, baseball, boxing. That's what I'm talking about. You know, I used to be a boxer when I was younger. I love it. Sleeping. I don't think sleeping is a sport, but that being said, I'd be really good at it. Tennis, yeah. Tennis, love it. Tennis. Eating, I don't think eating's a sport either, but I would certainly beat you at that. Anyway, the point is, there's lots of possibilities, correct?
There's some competitions for eating.
Oh, really? Oh, really? You can beat this? I don't think so. Competitive eating? I would so win. Anyways, the point, oh, competitive eating, that's what you meant. Like Kobayashi. Is that his name? Kobayashi?
Isn't it like a really skinny person who's able to eat a bunch of food?
Yeah. Kobayashi is very skinny. Although I think he lost it recently. I don't know. But that's just, yeah. Anyways, the point is, suppose I went to a Lakers game and I interviewed 1,000 people what their favorite sport is. Would I trust my data? Would
No.
why not?
You're in a basketball game asking about a sport.
Okay, so you can tell intuitively that there might be an issue there, correct?
Yes.
It's not really a mathematical issue. I mean, 1,000 people, that's a large sample. That's a very large sample, but there's something wrong with it.
There's a bias.
There's a bias. There's a bias. Bias is when, and we're going to actually define it soon, so I'm not going to say it right now, but there's a bias there. Now, there's lots of types of bias. Bias can come in many shapes and sizes. Suppose, here's one. One of the things you look for when you take a survey is honesty, correct? Can you imagine somebody lying about their answer? Don't you think that might throw a little wrench into your study?
Yes.
Okay, honey, does this make me look fat? Might that lend itself to bias? Now, for me, the answer is always yes, but that's besides the point. Everything makes me look fat. But the point is that some questions you might not get an honest answer from. Here's another one. And I preface this by saying there's nothing in this question to indicate my personal thoughts on the issue. It's merely an example for statistics class. So don't take what I'm saying as an opinion one way or the other. But suppose somebody came along and said, I'm taking a survey. Are you anti-abortion or do you like killing babies?
That's a loaded question.
Exactly. Okay, the wording itself is very much lends itself to bias, because what person would say, oh yeah, I like killing babies? Right? So sometimes
Yeah.
the wording itself might be enough to cause bias. Or what if I say, do you believe that African Americans should have reparations from slavery in the 1800s? Well, a white person asking versus a black person asking might lend itself to different answers. Can you conceive of that scenario? That the person asking the question might influence the answer.
Yeah, some people might like not feel that way, but feel since the person who's asking.
Exactly.
Yeah.
Here's a more recent one. And again, this is, I say nothing about my own personal opinion, but the political landscape is very, very polarized. And I personally know of people who are, if not pro-Trump, then at least not anti-Trump, that feel that they can't admit that to their friends because of stigmas and whatnot amongst their particular group of social construct. So if somebody asks them like, hey, who you're voting for, they might be disinclined to say what they really believe, right? There's lots of ways bias can come into the picture, correct? There's wording bias, there's interview bias, there's lots of ways bias can come into the picture. So this chapter on sampling is basically talking about different ways of getting a sample and the good and the bad ways of getting samples and things that you have to look out for when taking samples. And the truth of the matter is that you can write a PhD thesis on sampling. Okay, it is not as clear cut as 15 pages in a book. It's a very, very pervasive and important subject. And I'm not an expert in it. I can teach college statistics. I can teach advanced college statistics, but actually, if you ask me to go out there and actually gather data, I would say I'm not qualified for this. So there's really a lot to it. So the population of the people that you're getting the data from, all the individuals, the sample is a smaller collection. But what you need is a sampling design. And a sampling design is merely the process by which you are going to create your sample. You're going to go out there and you're going to stand by the entrance to the bookstore, and you are going to ask every fourth person what they had for breakfast. You just gave me a sampling design. You told me specifically how you are going to get your sample. Is it a good way? Is it a bad way? I don't know. But that is what's called a sampling design. Can anyone give me a different scenario of a different type of sampling design? A different way of getting your data.
You can just wait. Is this for like a specific scenario?
Yeah, give me a specific scenario. Give me any specific scenario.
Oh,
Use like the Google. When you use like the Google poll, like you just like send the link and then like everybody just like answers there. Like it's like
Oh, that's a great idea.
like I just feel like that's just much faster than like printing out paper.
Yes, that's awesome. Unfortunately, that's a horrible method of sampling, but it's a perfectly valid sampling design.
Mm.
But and I love that you mentioned it because it's like the very next thing we're going to talk about in the book anyways, is what's called a voluntary response sample. A voluntary response sample is when people decide on their own whether or not to respond to it. When you send out a poll and people respond or don't respond, do we see why intuitively that might be called a voluntary response sample?
Yes.
Okay. What is the problem with a voluntary response sample?
Not everyone does it.
But who does it?
the friend person
Who?
Oh, a lot of times it's like the friends of a person who like puts it up, and then oftentimes that person can have a specific group of friends.
Okay. Okay.
And also people can just decide not to do it midway after they see the question. So maybe like they might be inclined to just ignore it if it doesn't.
Sure. Have you ever
So it's
come?
like optional.
Yeah. Have you ever come across a voluntary response sample like on the internet, not from friends, just you're browsing and bam, there's a poll of some kind?
Yeah.
And when do you partake versus not partake?
When it's interesting to you, or
And it's interesting to you. Okay. People who respond to voluntary response samples are usually those with strong opinions on the subject, or it interests them, or they're friends of the person who put it out or something, but it's not representative of everybody. You know, I'm reading, you know, what's your favorite Harry Potter book? Like, who gives a shit, right? I just couldn't care less.
Sorry.
Sorry, what's that? You say something? What?
Like I care.
No, I'm saying my attitude is that. I'm not saying there's no one out there who cares. I'm saying for me, I couldn't care less. So I would not take a sample like that. But if it's like, what's your favorite Game of Thrones book? Then of course, you know, I would respond because, and that goes without saying. And by the way, everyone knows what their favorite Game of Thrones book is, right?
no.
You don't read Game of Thrones, huh?
Nope.
Does anyone here read it?
What is that?
Oh, what is Game of Thrones? Oh, just stop.
Game of Thrones a book before-
Anything with reading, you got me lost there.
I should what? What happened?
So wasn't it a book before it became a show?
Yes, it was, which is why I said, what's your favorite Game of Thrones book? I didn't say what's your Game of Thrones series. Never heard of it. You've been living under a rock for the last.
I don't like.
It's not in the 1800s.
I don't like Game of Thrones at all.
Oh, Clash of Kings. You
You don't like Sopranos? I don't like Game of Thrones.
that's fair. That's fair. that's totally fair.
But I was gonna ask you, the people who ask, like on the street, if they ask you questions,
Yeah.
Is that a sampling design?
Yeah. I mean, well, the sampling design is not just asking you questions. It's the process by which they choose who they're going to ask. So if they ask every person who walks by, that's their design. If they ask every 10th person, that's their design. Okay. However they choose to ask and how they construct their sample, that's their sampling design.
So sampling has to be like consistent in the design, or
No, but we call it it's called a systematic sampling. Systematic sampling. If I say I'm going to ask every fifth person, that's systematic, right? I have a process. I have an algorithm, very systematic. Okay. You ever see people in the mall and they're they're taking surveys and like they'll make eye contact with you and then they'll choose not to ask you,
Yeah.
or you avoid making eye contact with them because you don't want to be asked. I mean, hell, you walk by CSUN, this is before the pandemic, but in the quad, they used to be all over the place. These tables where they'd be asking you, hey, save the rainforest and save baby seals and let's, register for voting and do this and do that. Man, I just, oh my God, if they talk to me, I'm going to beat the shit out of them. That's how I feel sometimes. Okay. So in that case, the people don't have a system necessarily. They're going to pick and choose the people who they think might be susceptible to come by. Oh, that person looks nice and young. If I stop them, they'll give me the time of day and they'll talk to me. Oh, that person, he's or she's in a big hurry and very serious. I'm not going to waste my time. Okay. So systematic sampling, there's no picking and choosing. Systematic sampling, it's like, okay, every fifth person I'm going to ask and go on from there. That's a very solid way of sampling, systematic sampling, because you're removing bias that might come out from, oh, that person looks nice, that person looks this, that person looks that, and that might affect your results. Does that make sense? Yes, no, maybe so?
Yeah.
All right.
yes.
Okay, a convenience sample. A convenience sample or convenience sampling. It's convenient, right? It's convenient. You do something that's convenient. There's an example in the book, a sample of mall shoppers. Fast and cheap. Okay. You go to the mall, it's convenience. You stand in front of a store and you ask people coming in. It's convenience. Convenience sampling. Is that necessarily going to be representative of the entire population? If I go to the mall and I ask people who walk by a certain corner a question, is that representative of the entire population?
No.
Well, not even close, because who goes to the mall? You have, the old joggers, the power walkers, they go to the mall. And you have people who might be a little more wealthy might go to the mall. Homeless people won't go to the mall, probably. Back in my day, in the 80s, that's the hangout. That's where we all went. We all went to the mall. So you had a lot of young kids at the mall. Do you guys even go to the mall anymore? Do you guys do that?
Not anymore.
Yes.
I mean, if you go to the mall, it's the shop, right? You don't go there to hang out, do you?
No, I just
No.
go to buy stuff.
Huh?
I just go to buy stuff.
Yeah, you go to the mall to buy stuff. You don't go just to spend the Saturday at the mall. That's not like the hangout anymore.
Most of high schoolers, 9th through 10th grade, or 8th to 10th grade, go to
Yeah.
Yeah.
They go to the mall still? It's still a thing?
still a thing for high school.
Oh, that's so sweet. Okay, so we have voluntary response, we have systematic sampling, we have convenience sampling. Now, the best type of sampling, the best is called a simple random sample. And a simple random sample will be abbreviated SRS. So anytime in this course we talk about a simple random sample, we are talking about an SRS. Or vice versa. SRS means simple random sample. Does anyone know what a simple random sample is? So let's imagine you are the teacher and you have your class lined up. You got all these seats of all these people. Oh, I can do this better than this. Here you get all these people. Duplicate. Okay, you got all these people, got all these classmates. You got 1, 2, 3, 4, 5, 6, 7, 9, 4, 5, 6, 7, 36 people. Okay, you're teaching a class of 36 people. And you decide that you're going to pick at random 3 of them. So you're sitting in front of this class and you decide that you're going to pick at random 3 of them. How would you do it? Give me an example of a random way of picking 3 of them.
The stick,
Random.
popsicle sticks.
Popsicle sticks.
Did
What do you
they-
mean, like, huh?
They like put the names on the popsicle sticks and then they just choose them.
So you put all the popsicle sticks in a hat and you pick 3 at random?
Yeah.
Okay, interesting that you went with something that has your saliva all over it. But let's go with like, how about names in a hat? Like on a piece
It's
of paper.
because that's what they would do in like I remember that's how they would choose us to like answer questions and stuff.
Where?
I think in my elementary.
That's just weird. That's just weird. But okay, fair enough. Okay, so a nice way of doing it, if you put everyone's name in a hat or on popsicle sticks in a hat, and you shake it up and you pick 3 at random, does everyone agree that, yeah, me too, I know. Does everyone agree that that's a nice random way of getting 3 people?
Yeah. that would
Yeah.
be-
It seems like really nice, right? What about the following? What if I came along and said, okay, I'm gonna get one of you and one of you and one of you. Would that be random?
I don't think so, because you're actually choosing from a group of people.
Yeah,
Or
but
it can be.
But,
It can be.
but within that group, suppose I put the 12 people's name in a hat, picked 1 at random, 12 in a hat, picked 1 at random, 12 in a hat, picked 1 at random. So I got
Yeah,
3
it can
people.
be.
Is that
Yeah.
a random sample?
I guess.
Yes, but it's not a simple random sample. The word simple means that if I want to pick 3 people at true randomness, any 3 people are as equally likely to be picked as any other 3. In this method that I just did, is it possible that those 3 people will be picked?
No.
No.
But if I put their names in a hat, is it possible then that those 3 would have been picked?
Yes.
Yes. The hat method is a simple random sample because any 3 are just as likely to be picked as any other 3. Where this way, it's random, everyone has an equal chance to be picked, but not every group has an equal chance to be picked. The difference between random and simple random. Most of the formulas that are coming in the latter half of this course are going to require an SRS to be valid. So if it's not an SRS, now you're not actually going to take an SRS. The problem is it's going to say, assuming that you have an SRS, and just go with it. But you should just know that most of the problems require there to be an SRS before the formulas work. Again, what's a simple random sample? Whatever size of sample you have, any group of that size from the population is as equally likely to be picked as any other group. And in our example, we used names in a hat. But in general, I would use what's called an RNG. What does RNG stand for? Anyone know what RNG is? Not everyone at once. A random number generator, that's correct. A random
It's
number.
that thing on video games.
What? What video games?
Fortnite.
Fortnite. I never played Fortnite. I had my own video game that I used to play. It wasn't Fortnite though. Fortnite not addicting enough. Or is it? You addicted to Fortnite? Is that like a game that you can play for like 12 hours a day every day of your
Oh,
life?
I stopped already. That was like in high school.
High school. That's like 2 years ago for you, right?
Around there.
Around there, yeah. So when I was in college, I got addicted to a computer game. I think my GPA tanked like 2 points when I played it. But damn, that was fun. Anyways, a random number generator generates numbers randomly. So if I assign 1, 2, 3, 4, and so on, all the way up to 36, and I tell my random number generator, give me 3 numbers from 36, and it gives me 11, 17, and 4, well, okay, 4, 11, 17, you guys have been picked. And any 3 are as equally likely to be picked as any other 3. Does that make sense?
Yes.
So
Yeah.
random number generators are the best way of generating numbers randomly, which is why they're called a random number generator. Very straightforward. Okay. By the way, that method where I said divide into groups like this and then pick one from each group, that's also a method of sampling. And that is called stratified sampling. Stratified sampling, divide the population into groups and use an SRS from each group. Can anyone give me an example, a scenario where you might decide that the best thing to do is to divide the population into groups and then take a sample from each group rather than just take a sample from everything all together? Can anyone think of a scenario where that might be prudent? When would dividing into groups be a good option? Where you then take an element from each group.
Dividing classmates into groups and choosing one to speak for some type of project or something.
Okay, so you just made a you gave a group project to your class. Every 3 people were in a group, and one person speaks for the group, and that one person is chosen at random. Oh, I love it. I love it. Great example. Anyone think of another one?
Would gender work?
Gender, if you feel that putting everyone together, males and females, biologically at least, will somehow confound your data and you want to keep them separate. So you put them into groups, what are called strata, and then take a sample from each group. Maybe I want to do it by country or by state or by county or by voting district or by continent. I mean, there's lots of situations. Huh?
By age.
By age? Maybe I'm interested in, how prone people are to having car accidents. I would expect age to be a factor. Maybe I want to separate them by age before I do something. So there's many reasons why I might decide first to split them up into little categories. Similar to that is what is called cluster sampling. And cluster sampling is very similar to stratified sampling, and then very different. We first divide the population into groups, just like we do with stratified sampling. And we use an SRS to pick complete clusters. So what that means is, if I come back to this example here, suppose I want to pick 12 people from the class. Sorry, I lied. Suppose I want to pick how do I say this? Yeah. Suppose I want to pick 12 people from the class. So what I might do is first divide them into clusters of 4 each. And then I don't pick part of each cluster, but rather what do?
Choose the groups.
I pick the complete, I'll say, okay, I have 1, 2, 3, I have 9 clusters here. So I'll randomly choose 3 of them and I'll take the entire clusters. So I don't divide them and take a little of each. I divide them and take each, or at least some of the eaches, if that makes sense from a grammatical perspective. Does that make sense what I just said? The difference between stratified and cluster?
Yes.
Yeah.
Okay. I'm pretty sure that's, there's a few other ones. There's a census. A census is arguably the best type of sampling design. Because what do you do in a census? You know how the US has a census every 10 years? You guys know that? Every 10 years, the US takes a census. You guys know that?
But wouldn't that be like similar to like at will response?
Sorry,
Like,
I'm sorry, I can't hear two
Sorry.
people at once. So go ahead, one of you. Go ahead, one of you, please.
Oh, I just said, yeah, they just did it like not that long ago.
Okay, so what is a census?
That's like you like go online, you go online, you take the survey, you like put like how many people live in your household and like your information like that.
No, I get it. I know what questions are asked, and I've done a census before. I've lived through 4 of them, 3 of them, whatever, a lot of them. But what by definition is a census? In terms of a sampling design, what's a census? A census, every individual in the population is in your sample. You don't just take some of the population. You take everyone. Every individual in the population is in your sample. So the one that the United States does every 10 years, it's literally a federal crime not to be honest on it. If you lie on the census, it's a federal crime. Okay, censuses or censusi or multiples.
It's okay.
Thanks. I don't know how to speak good, but they're so important because they can actually affect government policy and spending. If people, if the population in this county changes, the government will attribute more funds or do this or do that, depending upon what the populations are. And when you lie, it can have devastating effects. So it's a federal crime. So a census is the best type of sample because you get everyone. Okay. There's also something called random digit dialing. Random digit dialing. And what do you think random digit dialing is?
You call random numbers.
You call random numbers. Do you see why random digit dialing might be a bad method of sampling?
Annoying.
It's certainly annoying. But I don't mean in terms of that. I mean in terms of a data collection process. Why is random digit dialing not a good data collection process?
You don't know what group you're specifically getting it from, your information.
There is that, but even more so, are you guaranteed to get a sample that represents?
No, not really, because people might not answer. Just hang up the phone.
People might not answer, or
Like I get phone calls like that, like scam likely every single day.
Yeah, I mean, I don't know about you, but I can save a lot of money on insurance if I switch to something or other. Or what's that latest scam I keep getting these calls on? You guys getting this?
The one where you like get like a text message and they're like, oh, you just won $100 like on Amazon, like, and you have to like click the link and like all that, or like they text you some other like BS.
I want to win $100 on Amazon. That'd be awesome.
Yeah, the car warranty.
Yeah.
The car. I actually have a kid in my class, my high school that I teach at. The kid's 13 years old, and he gets these calls about the car warranty. So it's kind of funny. Anyways, the point is that you might not respond. We call it non-response, by the way. Non-response is bad. If you take a survey and you say, okay, I'm going to pick 50 people from each state, and then you have the 50 people and you call them and they don't respond, or some of them don't respond, then that can introduce bias because then you might not have a representation from each state like you were hoping. So non-response is bad. But in this case, I'm not even talking about non-response. I'm talking about under coverage. Not everyone has a phone or or people have multiple phone numbers. So if you do random digit dialing, how can you expect to get everyone or a sample that can represent everyone if not everyone even has a phone in the first place? So there's a segment of the population that you'll never get to because they don't fall under the purview of what you're looking for. Does that make sense?
Yes.
So under coverage and non-response are two ways of introducing bias into an experiment. We talked about that before. So let's take a minute just to talk about bias. Right? There's under coverage that can introduce bias. There's non-response that can introduce bias, non-response. There's wording bias. There's interviewer bias. There's just straight up someone lies. That's called something. I forget what it's called. But there's multiple ways that the bias can be introduced, or just like the basketball example. The basketball example is biased. We'll just call it scenario biased, right? Based upon what's happening and the way that you took your design. There's many ways of introducing bias, and biases are bad. So try to not have bias. Response bias. That was the word I was looking for. Response bias. The people respond and they're lying, or they're mistaken, or whatever the case may be. But there's, for whatever reason, it's just the inferences that you're trying to make from your data will not be accurate because of all these problems. Okay. Any questions on anything that we did today?
Not really.
It's not mathematical, this chapter. It's very, very qualitative.
Oh, I have a question. Is there a specific number of like you're supposed to know for sampling, or?
We will certainly investigate that question as the semester progresses.
Okay.
And we will have scenarios where we actually compute appropriate sample sizes for different scenarios. But I will say that in general, the two things that you're looking for in general, actually, I'm going to move this down here. In general, the two main what's the word I'm looking for? The two main desired attributes of a sample are randomness and replication. Okay, you want it to be as random as possible so that there's no bias, and the more data you have, the better. So if I go out there and I say, oh, okay, who are you voting for? And 3 people say Trump and 2 people say Biden. I'll be like, oh, sweet, Trump's gonna win. That 60% of voters are going for Trump. Yay, 3 out of 5, 60%. Would that be a valid inference from the sample to the population?
No.
Why not?
Not enough.
Yeah, it's a very small sample, right? I mean, in 5, anything can happen. I can get 5 Trumpers. I can get 5 Bideners. Is that even a word, Bideners? I don't know.
I don't know.
I just made it up. Okay, I can get either 5 Trumpers or 5 Bideners. So anything can happen with a small sample, which is why the bigger the sample, the better. The bigger the sample, the better. And by the way, Lahid, I'm looking back. You see the Clash of Kings. I disagree. I think it's Storm of Swords, but that's just me. Anyways, are there any questions otherwise on anything we did today?
No.
No.
Okay, well then again, so that's it for today. I just wanted to cover chapter 8, which we did. I'm going to put up the homework. If I forget, just remind me, but I'm going to try to do it.
Yeah, how's the homework going to be if it's not math? Is it just going to be like multiple choice, fill in the blank question?
Probably, or something along the lines of what kind is this, or what kind is that, or what's wrong with this, or what's wrong with that? Is this good? Is this bad?
Okay.
No, it's not mathematical. No, and next chapter also won't be mathematical. But then, have no fear, the math is coming.
Yay.
I know. I missed what you said about skipping 6 and 7. We skipped 6 and 7 for 2 reasons. 7 is not really a new chapter. 7 is just a review chapter. So we don't do 7. And we skip 6 because 6 goes very well with 24. Essentially, we don't need 6 until 24. And so we do them together at the end. So we're going to get back to 6 eventually. But 6, until you learn 24, 6 is kind of just like, why are we learning this? We're not using this at all. But then you learn 24 and you're like, oh, now I get it. So rather than doing 6 now, I just do it with 24. Does that make sense? As to my motivation, the madness,
Sir,
method of my madness. Yes, what?
I said yes, sir.
I love it. Yes, sir. I feel good. Okay. Well, then I'm gonna stop recording if there's no other questions. Are there any other questions?
I have a
No.
question. Can you tell us what interviewer bias is again?
Yeah, interviewer bias is when the interviewer himself or herself lends itself to bias. So, for example, if I ask a woman,
Oh, like if you know the person or
well,
something.
certainly if you know the person, but if I ask a woman, for example, a very a personal question where it's inappropriate for for a stranger to ask, or for a woman to ask a man something similarly, it might just lend itself to uncomfortable situation and just not being honest, right? It's not nothing wrong with the question itself, but it's just the fact that I'm the one asking might in and of itself create bias.
Would it also
Okay,
have to
thank
do
you.
with like their method? Like if they were purposely choosing certain groups of people?
Well, I would say that's more not so much the interviewer him or herself, but rather the sampling design.
Okay.
It was the bias comes from the design, not from the fact. Because for the interviewer bias, it's basically if it was a different interviewer, would the answer be different?
Oh, okay.
Okay. Everything else being equal, is the interviewer the one causing the bias? Is the wording causing the bias? Is it the response that's the bias? So basically, try to imagine everything else is the same, but I make one change. What happens because of it?
Okay.
Make sense?
Yeah.
Okay, then I will see you guys on Thursday evening, at least to start at 6:30. My flight's at 8:45, but I'm going to try to get to the airport so I can be settled by 6:30. If I'm late, I would say I am playing doubles in Arizona, yes. If I'm late, I would say 7 o'clock. Okay, give me a half an hour. So class is at 6:30. If by 7 I'm not there, then technical difficulties, I'm not coming. But I'm gonna try as best I can to be there by 6:30. Okay, is that fair?
Fair enough.
Okay,
Yeah.
and if you're here, if you're all here together at 6:30 and I'm not, feel free to work on the homework. Feel free to talk about statistics and try to get a better understanding. Use the time wisely. I mean, I will try to be there. But if for whatever reason I'm not, use the time wisely. You probably won't, but I'm asking you to do so.
So is then like is office hours for Thursday, is that also gonna be canceled?
Let's assume that's the case. That's a good point. I highly doubt I'm going to be there for office hours. I mean, I might, because let's see, if I leave for the airport at 3, I mean, yeah, by 5:30, I mean, I'm hoping to be there by then. I'm certainly hoping to. So listen, stop in. If I'm not there, I'm not there. If I am there, I am there.
Cool.
Okay. All right, everyone.
All right.
All right.
Thank you.
Okay.
Good
Have a
night.
great.
Thank you.
Thank you guys.
Good night.